Ladies and gentlemen, do you know how the oil and gas been delivered from the oil and gas industry to the other destination? So the first way is we usually see on the road, which the oil and gas trailer, and it's only delivered to the oil pump station. Then the second way is we using the offshore ship, and it can carry a massive amount of oil and gas, but its delivery time takes so long. So the last one and the one that we focus on is the oil and gas pipeline. It also can deliver a tremendous amount of the oil and gas, and it doesn't take long to deliver for the long distance. But what actually the problem that we face in the oil and gas? So firstly, as we know, the movement of oil and gas from one point to another point is so fast, and it will create the high pressure inside the pipeline. Then it will make the particle of oil and gas collide with the inner surface of the pipeline. At a certain period of time, the thickness of the oil the thickness of the pipeline will become thinner because of corrosion, and the worst scenario is the leaking of oil and gas will happen. So the natural disaster as the earthquake also can make the pipeline broke, and it will make the leaking occurs. So if the oil and gas leak occurs, so it exposed to the environment and very harmful to environment such as any forest, animal and human itself. So we need have a solution to overcome this problem. Maybe we need a system which can monitor the leaking of on oil and gas pipeline to overcome the problem that I mentioned before. So in my research, about the oil and gas pipeline leaking, I would like to introduce the BOTDR fiber optical sensor as a monitoring system in the oil and gas pipeline. The meaning of BOTDR is Brillouin optical time domain reflectometry, and it uses the principle of Brillouin structuring. So my objective for this research is to simulate the BOTDR fiber optic sensor by using the optic system. And the second one is to analyze and optimize the output parameters, which the change of strain and temperature, sensing distance and signal to noise ratio. So the method that I use to design this BOTDR fiber optic sensor is by using the optic system, and it is the simulation software. In order to design the BOTDR optical fiber sensor, it needs the configuration for it to create, and this is the the configuration that I use to design the BOTDR sensor. So you can see that I use a laser as a source for this sensor, and it connected to the modulator to create the pulse input. In order to modulator work properly, so these two generator was connected to the modulator to make it work well. So at the optical fiber, the length that I use is around 10 kilometers, and the normal temperature at this optical fiber is 300 Kelvin. So if they have any temperature change, either become cool or hot, so the optical fiber will detect and produce the output at the optical time domain visualizer, and it shows as the frequency graph. So my conclusion is, if we can implement the monitoring system in the oil and gas pipeline, the first benefit is we can have a low cost to implement the BOTDR sensor in the pipeline, because it can detect the leaking in the pipeline for the long distance. The second one is we can save the environment from the harmful of oil and gas leaking. The last one is we can have a low maintenance to the pipeline, because it can detect the leaking more quicker and make the oil and gas company to alert and have a scheduled maintenance to avoid the worst scenario. So that's all from me. Thank you.